I'll give you some suggestions for creating the Manchester pulse, and it needs the bit interval as well as the sampling frequency. The product of those two numbers tells you the total number of samples that need to be generated, and ultimately you are generating an array. The Manchester pulse needs to look like 1 for the first half of the interval and -1 for the second half of the interval. And I'm simply finishing up here the generation of an integer that represents the total number of samples to generate. Now, a number of different options exist. You could certainly, if you feel more comfortable with math script coding, you might set up a math script node for this purpose. I'm going to do this in G, or LabVIEW graphical code. This construct will divide the samples per interval in two, and specifically it's doing integer style division, so it always produces an integer result instead of sometimes an fractional result if we had ultimately an odd number of samples. You can create an array constant filled with either the -1 or the +1, whichever you see fit. And then you might use the replace array to then swap out half of those array values based on the essentially samples per interval divided by 2 that's been calculated just now.